Lesson 3, Trimmed Mean. So when we're dealing with data, sometimes we have things that are called outliers, and what that means is it's significantly outside of what you're generally dealing with. Lots of the times you can justify your reasoning why or why not you would choose it. Sometimes we won't all agree on what outliers are, but generally you should be able to tell if something is significantly out of the norm. So when we have a trimmed mean, what that means is we're going to have the mean without these outliers, and it's a more approximate version of the mean because the outliers, what they do is they skew the data one way or the other. So a lady makes quillwork bags with hand-sewed bead designs. The hours spent on the quillwork determine how much she charges for the bags. Here are her last 10 purses she's made. I want you to put those in order from smallest to biggest and pause the video and then do that. Okay, looking at this, here are our numbers in order. So if we were to find our median, there's 10 numbers. So our median would be our two middle numbers, which would be our fifth and our sixth numbers, which would be 7.5 and 8. 1, 2, 3, 4, 5. So 7.5 and 8. So our median would be roughly 7.75. So we're just going to keep that in mind because that's kind of our middle number right now. We're going to find the mean of this data, so I want you to pause the video, add all those numbers up, and tell me what you get. So you should have got 99 when you added it. We're going to divide it by 10, which is 9.9. So that is my mean. So we're just going to leave that right now, and then we'll compare it in a little bit. So in order to find the outliers, or the trimmed mean, we need to find the outliers. So looking at this data, this 3 looks pretty far from the normal, as well as definitely this 37. 5 through 9 seem pretty good. And reasons this could be happening is this 3 could be a very small design. It doesn't take her very long. But this 37 is probably a very complicated one. It's not something in the normal for her. So we're going to say that 3 and 37 are outliers because it's just too far away from 7.75, which is our middle kind of number there. So we're going to do the same thing we just did for the mean, for the trimmed mean, but we're just not going to add up the 3 and the 37. So there's two ways you can do it. You can either take this 99 and subtract 3 and 37, or you can just re-add all of these numbers up together, whatever you want to do. So I want you to pause the video and do whatever way you feel comfortable with. What you should have got was the number 59. And now, because we took 2 numbers out, we're no longer dealing with 10 numbers, but we're dealing with 8 numbers. So the trimmed mean is now 7.375. And what you should notice is it's matching this median a little bit more. So we're going to visualize this. So to visualize this, we have our trimmed mean and our mean. If we were to put our data in order, so here's our data in order, we know that the trimmed mean would be in here. And it would be our 7.375. If we were to take our actual mean that we got 9.9, which would be right here. And that was our normal mean. So what you should be able to see is that is nowhere near the middle of the data. If we're talking about measures of central tendency, it needs to be in the center. It needs to be central. Our mean, or our median, was right about here. So if you look at it, this trimmed mean is the best for approximating the middle of our data. So this 3 and this 37 skewed it. So part D is just asking why might there be outliers in this case, so I kind of already said that. Maybe the design did not take very long, or it was something that was very intricate, but is not in her average workload. So it still happened, she still charged for it, but it would skew her data.